Good day, Algebra. We are starting PO7. Is this the last objective of our unit? Did I say? No, it's not.
PO7 P1 and PO7 P2.
Oh, there's a part. Okay. So we're getting to the end. And it's multi-step equations. On your entrance exam, this would cover objectives 60, 61, and 62. Okay. So if you need to retake 60, 61, and 62 from the entrance exam, well, the good news is we're learning it again here. So it'll help you prepare for that. So you have seen this before. Last year was 3 objectives. Now it's just 1 objective where you shove everything in. Okay. And it's basically multi-step equations, which means it's more than 2 steps, right? CO6, we kind of reviewed how to solve 2-step equations. You have the constant, you have the coefficient, opposite operations. In multi-step, there's more stuff you got to do in order to get it down to a 2-step equation. And the first of those extra steps is combining like terms. Tell me what you remember about combining like terms. Maybe look at some examples of combining like terms equations, and how do you combine like terms? What are you looking for, Maddie?
Combining like terms,
Yeah, and why do we do it? You know, how would we combine 9x and a negative 4x in this first example here? You have 9x's, you take away 4x's. So how many x's would we have? 5 x's, right? It's just simpler, okay? To combine like terms is to simplify an expression, right? To create a 2-step equation. I want the 2-step equation to be like your comfort zone. Like once you get there, you're like, all right, I got this. I know exactly what I need to do. Move my constant over, divide by the coefficient, add, subtract, whatever it is, okay? And so as Colin said here, you know, if you've got 9 x's and you take away 4 of them, well, that's just like having 5 of them, right? I buy 9 tacos on my way home from school. I eat 4 of them on the way home. When I get there, my wife asks, how many tacos you get? I got 5. Okay, so 9, take away 4, you just have 5. So 5x plus 3 equals 43. Why can't we add 5x and 3? We may have talked about this yesterday as well. Ryan, yeah, you were super excited about that. Right, they're not like terms, right? The 3 doesn't have a variable. It is a constant. You cannot combine constants with variable terms. But now we're at a 2-step equation, aren't we? Yay, what do we do? Yeah. Subtract 3, again, opposite operations to move it over, because 5x has to equal 40, so that when we add 3 to that, we get to 43, right? That's why we subtract 3. We're undoing the equation. Second step, Paisley. Divide by 5, because we don't care that 5 x's make 40. We want to know what 1x is. And if 5 x's make 40, we divide those 5 x's into groups of 1x, and 40 divided by 5 equals 8. Okay? Tell me how you what's the 2-step equation that we would get from the second one? Or do you have a question, Cole? Okay, what's the 2-step equation we get from the second one? Cole? Sorry? Okay, and what would we get? Good. 8n and a negative 11n. Remember the subtraction sign belongs to the 11. Okay, it's a negative 11. And so you have 8 n's, you subtract 11, and you've got negative 3n plus 2 equals 29. All right, negative 3n plus 2 equals 29. From there is a 2-step equation. Subtract 2, divide by negative 3, and we get n equals negative 9. Okay. The next one, what would that one simplify to be? Take a look at those like terms there. Nathan. Please. Oh, no, not that answer. So how would we simplify the expression, Nathan?
So you do negative 10n
Yes.
minus 2n,
Good.
which is negative 12n.
Good. Negative 10 minus 2. It's important to know which direction to go, right? Negative 10 minus 2 would not be negative 8. Negative 10 minus 2 means you're starting at negative 10 and going left, further away from 0, which will give us to, or bring us to negative 12. Carry on, sir.
And then what I did is I did before the 12 I put the 7 because it's minus, so it's already that. And then I put the 3 after the negative 12, and then I put them both into the big number and then divide it.
Okay, so what do 7 and 3 combine to be? Because they are constants, so they can be combined together. They make 10. So whether you put the 10 in front, so it's 10 minus 12n, or you put the 10 after, so it's negative 12n plus 10. Either way, the 10 is positive. So the positive 7, positive 3. So negative 12n plus 10. Here's our two-step equation. And then, as Nathan said, we can go to town from there. Subtract 10 from both sides. Again, be careful of that negative number minus something. Negative 122 minus 10 is a negative 132. You're going further away from 0 again. And then you're dividing by a negative 12. And as Nathan correctly predicted, it is 11. It is 11. Okay? We're obviously going through this much faster than we went through it last year, learning it for the first time. That does not mean I can't pause to answer questions, though. So anything that is not sitting well, where you know you made a mistake on the entrance exam someplace, you're working through practice work and can't quite remember what to do. We're good? Okay. All right. Next up is the distributive property. What's your clue that you're going to need to distribute when you're looking at an expression or an equation? You see this, and you're thinking, I've got to distribute. Katie, parentheses. And what does the distributive property do? It eliminates parentheses. Okay. The goal is to distribute the coefficients to eliminate parentheses. Distribute the coefficients to eliminate parentheses. And what operation do we use when we distribute the coefficients? Leah, multiplication. We're going to distribute that 7 in. 7 times 3n is 21n. 7 times negative 5 is a negative 35. The right side of the equal sign, that 7, not affected, right? It's not inside the parentheses, not even on the same side of the equation. Nothing changes with that, but now we have our two-step equation, and we can go to town on solving that. Add 35, divide by 21, and we get n equals 2. The next one. Ooh, what do we do first here? Paul? Brilliant, Paul. Brilliant. Why can't we subtract 7 and 2? It's so tempting to subtract 7 and 2 and put in a 5, but why can't we do that, Paul? Right, order of operations, okay? We have to multiply, which is what this operation is, before we subtract. And Paul went even one step further. My next question is, what do we distribute? What's the coefficient? Paul said negative 2, which is brilliant. That subtraction sign belongs to the 2. Okay, so the 7 just comes down because we didn't use it yet. And then negative 2 times n is a negative 2n. And this is why that sign's important, because it's a negative 2 times a negative 6, which gives us positive 12. Positive 12. Okay, there's one like that on the practice work for PO61, where you have to distribute that negative sign, which causes the sign inside the parentheses to change. Okay, and what would our next step be here? We're still not to a two-step, so I'm still not quite comfortable. What do we do, Colin? Which are?
7 and 12.
Good. Our constants, 7, positive 12. 7 plus 12 is 19. Whew. 2 steps. I can do this now. Subtract 19, divide by negative 2, and n equals negative 10. Next one. What am I distributing? Kaylin?
Isn't there an invisible one there?
There is. My poster in the back, that hidden math, shows all those things that we don't write because we're lazy. 10 is really 10.0. Can also be 10 over 1. When you have a variable by itself, it's like there's a 1 in front of it. And one of those, oh, it doesn't even have it. Well, that's embarrassing. I thought I did. Anyway, what we're going to add to that is that in this case, it's not written, but you've got a negative 1 in front of that. That subtraction sign, it doubles as a negative sign, and what it refers to is a negative 1. So negative 1 is what gets distributed into our parentheses. The 3t comes down. We'll deal with that later. Negative 1 times 8 is a negative 8. And negative 1 times a negative 2t is a positive 2t. Basically, putting in a negative 1 just changes the sign of everything. 8 becomes negative, negative 2t becomes positive. And the 12 is unaffected because it's not inside our parentheses. Now, like terms, get a new voice. Somebody I haven't heard from yet today. I've heard from you. I've heard from you. I've heard from you. I've heard from you. Nick! Oh, I've heard from you. I've heard from him. What can we combine is my question. Sam? Yes. 3t and a positive 2t is a 5t. And there's our two-step equation. 5t minus 8 equals 12. Add 8, divide by 5, and t is 4. Questions on the distributive property? There's one more type of multi-step equation that we're going to get to, and it is variables on both sides. Variables on both sides. And this one gets confused a lot with combining like terms because you are kind of combining like terms. But the difference is with combining like terms that we already talked about, your variables were on the same side, right? Here they're on opposite sides. So how does that change the process? Very good. The goal is to combine, I should say to move variable terms to move them together using opposite operations. Okay, to move variable terms together using opposite operations. I've got a great analogy for this, so stay tuned. Don't fall asleep yet. I got a good one here, right? But in that first one, 16x minus 5 equals 12x plus 23. Does it matter which side you put the x's on? No. Will you get the same value for x in the end anyway? Yes. So if you are a positive person and you like to keep things positive, then you might decide to subtract 12x from both sides to move your variables over to the left. Because if you take away 12x's from the right side and take away 12x's from the left side, have you kept the equation balanced? Yes. So is that legal to do? Yes. And you're left with 4x's on the left then your minus 5, and all that's left on the right is the 23. You have a two-step equation. Okay? If you did it the other way, if you think that a little negativity in life keeps you humble, and you want to move your 16x's over to the right, you could subtract 16x from both sides. On the left side, you have no more x's. You've canceled them out. You are left with a negative 5. 12 minus 16x is a negative 4x, and then you have your plus 23. Yes?
I moved the constants first, so I guess I'm just special.
Yes, moving the constants first, that's fine too. Either way, it works out. That's nice. We talked about this before, I think. The nice part about math is there's so many different ways you can get to the answer. As long as you're doing legal stuff, then it's all good. Solving this one, add 5, divide by 4, we get x equals 7. Add this one, subtract 23, which gives us negative 28 equals negative 4x. Notice how we still get positive 7 as an answer? Because now we're dividing a negative constant by a negative coefficient. And a negative divided by a negative equals a positive. Right? So it doesn't matter which side you move them to. You will get the same result because math is amazing. Okay? But here's my analogy. Right? If ops operations doesn't quite jive with you, think about a basketball score. You've got 16 x's on the left and 12 x's on the right. If you're in a basketball game and you're ahead 16-12, what's that really the same as being? 4-0, right? You're up by 4. So having 16 x's on one side and 12 on the other, that's the same as having 4 x's on one side and 0 on the other. Or if you're on the losing end of this, which would never happen at St. Vincent, obviously, but if you were, you're down by 4 because the other team is ahead. Took me 14 years of teaching to come up with that one. It's a goodie. What? Because I showed 3 different ways to do it. I'm glad you were paying attention. Okay. Okay. All right. So the next one. If we think about this as a basketball score, which since they're both negative, is a little bit trickier, but which is the greater value, -8 or -5? -5 is the greater value. By how much? By 3. So how many more n's do we have on the right side? 3. So we could write this to be 3 on the right and 0 on the left. Mathematically, if you're like, no, I need my opposite operations. If we add 8n to both sides, because -8n plus 8n cancels this out, -5n plus 8n is positive 3n. Okay? And now we're at a two-step equation. Awesome. Right? I'm going to save the next two for Monday when we cover this again. No homework, right? Except for your Khan Academy. For your, hold on, folks. For your planning purposes, we will finish this up on Monday. We'll do CO8 on Tuesday. We will see if CO8 takes us a second day or not. Maybe PO7 will take us into Tuesday. Either way, plan on a test next Friday, which means that we will not have a retake day in class next Friday. I'm giving you enough notice, so if you have to stay after school next week, Monday or Thursday, plan ahead. But no retake day next Friday. We will instead be having our first test, which is like right before conferences, so it works out very well. All right. No homework for Monday except for Khan Academy, working in math back at That's How You Math.